I lead the strategic reasoning group within the Artificial Intelligence Lab. We study strategic domains, automating decision making when there are other rational agents around. We do that in a variety of domains using techniques from agent-based modeling and computational game theory. Given the theme of AI in society today, I thought I would focus my remarks on a paper that I recently published with a colleague, Uday Rajan, who's the head of the finance department here at the Ross School of Business, that tried to explore at a very high level how you would draw some lines in thinking about ethical issues for essentially algorithmic trading, autonomous trading agents. But before I get into that, I thought I'd just say a few words about why would an academic computer scientist be focusing on the finance domain in particular. Well, as we certainly found out in 2008, if we didn't believe it before, the financial sector is critical for the global economy. When it goes wrong, the economy stops working. We lost trillions of dollars worth of productive output despite nothing breaking, no earthquakes or destruction of assets or forgetting how to make stuff. It was just a miscoordination of decisions about allocations of resources over time. That is, we found out that this financial system is very fragile, and maybe that shouldn't be too surprising because it's made up entirely out of information. What the financial system is, it's a series of bets, very interconnected ones, that everybody is making and interacting with everybody's allocation of consumption over their time. Some are investing for the future. Decisions are made on what to invest in based on what we believe will actually be valued in the future, what technologies will actually work out and get adopted. Very uncertain things, and when our beliefs or expectations all of a sudden shift, then our very complex economy can have problems. In fact, it's amazing when you really look at it that it ever works. This seems fascinating from a computational perspective as a computer scientist. How does this system of, which is essentially all these computational entities interacting, work? So we are very interested in that. And to cap it all off, the financial sector is already highly infiltrated by artificial intelligence. If you think that someone says the word trader, financial trader to you, you might conjure up an image of these guys in something called a pit shouting out stuff. Actually, they no longer exist. Right now, really, when you say trader, you should be thinking of this. A bunch of computers in a big, heavily air-conditioned room buzzing away, making decisions in financial markets. When we talk about the prospective displacement, AI and the labor force, these guys, like I said, I know some of them. They're doing okay. They found some other things to way to earn a livelihood. But right now, this image is really just for TV. Actually, it's pretty amazing. 10 or 15 years ago, it may have seemed surprising that one of the first applications of fully autonomous agents would be in making high-stakes financial decisions without humans in the loop. Why would that be? Well, one is that it's actually, for AI, it's simple in some respects, is that it has a very well-scoped interfaces. Trading in the financial markets, you submit orders to buy or you sell, you cancel them, you get information in a very structured way. We can build those interfaces easily. Financial markets have high data volume and velocity. This is really in the wheelhouse for autonomous agents. They can process much more information from many more sources much faster than people do, which is different than better in every way, but faster, no doubt about it. And when reaction to information quickly is what matters, there's just no competition between humans and machines. We talk about these traders making decisions in a blink of an eye. Well, a blink of an eye is about 300 milliseconds. And in that time, the algorithmic traders have gone back and forth 100 times with each other to decide what to do. And they work, and so once there's a source of getting money from this, of course they get adopted, despite maybe some potential risks. So that's something that we maybe should be looking at. And it's not just trading. There's other aspects of the financial system that AI is involved in, but I'm not going to go into that now. Okay, so what? So we go from humans trading to machines trading. On the internet, nobody knows you're a dog. What difference does it make? Well, maybe there are reasons to think that it's qualitatively different. One is the speed and precision, which I just mentioned. That's unprecedented, and we maybe don't know what to expect. Because of that speed, new strategies can be implemented that were not possible before. If a strategy involves taking information from 10 sources and then taking actions in 12 different places within the same tenth of a second, that's not something a person or even a team of really well-coordinated people with telephones can do. That's something you need machines to do. New strategies that involve taking advantage of these very, very tiny information advantages called latency arbitrage, anticipatory strategies that make predictions in millisecond timescales. Okay, predicting the future is hard, but predicting the next few milliseconds is not always so hard, actually, if you have some advanced knowledge. So these kind of things are possible. And maybe they can think of new ways to scam or fraud or manipulate markets. Because of the speed, they have to be autonomous, right? We can't have a human in the loop. They go together. Well, when they're autonomous, that means that the programmer should have, or the programmer of the algorithm, or the learning algorithm that came up with the strategy, they would have had to think about all the situations that we could get in. Maybe they didn't think about everything. And finally, we have an unprecedented scalability. That is, if you have some new trading strategy idea, you can put it in the New York Stock Exchange today, and of course every other equity market in the United States and in Europe and in Japan and everywhere, and not just equities, but corporate bonds and foreign exchange and Bitcoin, or whatever. It all can happen all at the same time. Okay. This has kicked off a latency arms race. We just had a session on arms races before, a different kind of arms race. But here's where you have a winner-take-all situation about response time that has led to massive investments on shaving milliseconds and even microseconds off of response times that at best has probably been a big waste of resources. If all you manage to do after spending hundreds of millions or billions of dollars is make what was going to happen a millisecond earlier than it would have happened anyway, the markets really are no longer more efficient, but that those hundreds of millions have been spent. Because of that, there has been some controversy. There's the Michael Lewis, of course, and his Flash Boys, but many others have worried about the implications of high-frequency trading and algorithmic trading in general for financial markets. So what we wanted to say is, are there ways, obviously we would like that for the laws and the regulations to be adapted to possibly address some of these new features that are special to a world of algorithmic traders. But, laws and regulations change pretty slowly compared to technology and can often lag far behind. Is it possible that we can set other norms or principles as a stopgap? There are certain real challenges, and this comes with all kinds of autonomy. When somebody programs an algorithm that goes and do something that gives them a little bit of an indirection in which to maybe evade accountability. Much of the law is written for a world where people make decisions, not machines. And because of that, they hinge on issues of intent, which are actually pretty tricky to establish for people often, but you can interrogate them in certain ways that may be a little bit sometimes harder to interrogate, say, learned strategies. So I'm going to skip a little bit here. What we developed was a system, a framework we called RBOT, an arbitrage bot, to try to characterize what we could consider to be a generic architecture for AI-based trading agents. And we classified them into 4 levels of aggressiveness. So one is passive search for opportunities. So these agents are good for monitoring lots of stuff, finding opportunities, and jumping on them. That's usually pretty benign, in fact, helpful in making markets more efficient. But once you're really good at this, then you have an incentive to amplify those opportunities showing up. So you might want to do things that affect the markets so that they get into a state where you have an advantage. That's a kind of a manipulation. Humans do this too, but there's a possibility that AIs can do them more. So spoofing markets is an example. The third level is where you actually structurally change things to create new opportunities. So introducing new financial instruments or fragmenting markets, that's something that's been done. And fourth is malicious subversion of markets. We've actually done a lot of work on level 2. We have a project on spoofing, or on detecting market manipulation. As shown here, the standard regulations, as I indicated before, are based on intent. One thing that we've done, which I'm going to illustrate briefly, is try to see if we can recreate spoofing in the lab. That is, build a model where agents try to manipulate the market and other rational agents are misled. This is something that really happens all the time. It's been in the press a lot. There's actually been some recent prosecutions, and we have succeeded in reproducing it. Some of our current work is on trying to understand when it can happen, how can we design markets to make it less likely to happen. We had a paper in IJCAI earlier this year on mechanisms that hide certain information that might make them more robust to these manipulations. We're also wondering to what extent does learning make manipulation potentially worse? Can agents automatically learn them? And this is kind of the nightmare scenario where I can say, look, I just ran my deep reinforcement learning algorithm and asked it to go try to figure out a way to make money. I didn't realize that what it was going to learn is how to scam people and how to do that. But we think that that's actually probably one of the easiest things to learn by trial and error. Okay. So I think I will. Do I have jump to the concluding slide? Financial markets and finance is a very critical domain, and it happens also to be at the leading edge of automation by AI. There's not that many people studying it. There should be more. We think it's really fascinating. It brings in not just a technical AI perspective, but economics and law and policy dimensions. There's quite a few tricky issues. We think it might be possible to draw some lines that are helpful to guide policymakers, but I think it's going to be a challenge to really reshape the legal and regulatory system to totally properly adapt to this brave new world. Thank you.